diagram and absolute value to determine the lengths of the line segments. Remember, we are looking for the point at A. It's that red dot, not the letter A. It's a little tricky because the letters might confuse you, but they're talking about the location of that dot. And I've just gone ahead and colored them red so you can kind of distinguish between the point and then the letter that's names the point. So for point A, we go left 1, 2, 3, 4, 5, 6, 7. And left is always negative. And then we went up 1, 2, 3, 4, 5, 6, 7, 8. And up is positive, so negative 7, 8. Now looking at point B, we need to go right 1, 2, 3, 4, 5. And right is positive. And then we need to go up 1, 2, 3, 4, 5, 6, 7, 8. B is also used in this one. And now we need to look for C. C is also right 5. But it's only up 1, 2, 3, 4, 5. C is also used in this line segment. Oops, that should say 5, not C. 5, 5. And D is left 2 and up 5. E is also left 2, but it is down 4 from that origin point. So left 2, down 1, 2, 3, 4. E is also used here. And F. F is left 1, 2, 3, 4, 5, 6, 7. And down 4. And A, we use that's at the beginning point, negative 7, 8, that first one that we did. Now we go through and we cross out all the things that are the same about them. And now we're going to work with the absolute values in our proof. So I'm going to put the one that has the bigger absolute value first. That way if we are subtracting, I'm still going to end up with a positive number. I've got 5 and negative 2, 5 and negative 4, negative 7 and negative 2, 8 and negative 4. Okay, if they have the same sign, we subtract. The only ones that I notice have the same sign are this one here. They both are negative. Oh, and this one here is both are positive. The rest of them have opposite signs, which means we need to add their absolute values. 7 plus 5 is 12. 8 minus 5 is 3. 5 plus 2 is 7. 5 plus 4, right? The absolute value of negative 4 is a positive 4. So 5 plus 4 is 9. 7 minus 2 is 5. And 8 plus 4 is 12.